Hello, welcome to this another tutorial on Java. So we have been discussing about the Java collections, and today we are going to discuss about the queue interface. We have discussed list interface, we have discussed the set interface, we have discussed about the map interface in the previous videos. If you have not watched those, please go and watch those videos. But today we're going to just discuss the queue interface. So what's a queue interface? So this is another interface, and as you know, the queue is just some kind of line. When you want to process, or your program has some kind of need where you want things to be processed in certain order, then you can use the queue. So this queue or line, if you go to any supermarket, if you want to pay for your purchases, you stand in a line, and that's basically line is just a queue. Actually, the first person who is in the line, he pays first, then the second one, and people are added to the end of the queue, and people are really served from the beginning of the queue. So you get the point. So we have queue. Let's say person one comes first, then second person comes, then third person comes, then fourth person comes, fifth person comes, and the way it processed is first person is the one who gets processed first, then the second one, then the third one. If more people are coming, they're just getting at the end of the queue actually. So this is simple concept of queue, what we have seen in day-to-day life. So your program might have some kind of needs where you want to process the things in certain order. Like let's say you have a website, the orders are coming in certain order, you want to process them in the order they come. So the queue is one of the examples you can use there. So we have this queue interface, and we are going to discuss this. There are three implementations. One of them is with the linked list, and linked list really simulates this FIFO operation, which is first in first out. So this is like a queue. First person who stands in the queue, he's served first, then the next, and the next. So that's why it's called FIFO, first in first out. Whoever comes first, he's served first. The second implementation is priority queue. So the priority queue is not a first in first out. In this priority queue, the elements of this queue are processed according to the priority, and the priority is, this is just a natural ordering is used if you don't provide any comparative. So what it means in natural ordering mean, if a person has number one, and so let's say you get some kind of tokens at some place where you need to be served. So person who has the lowest token, like number one, he gets served first, then the other person, those kind of things. Or you can also take an example of let's say you go to this is just example of, let's say you have bugs in your program and you're trying to log those bugs into a system, and you always put some kind of priority on those bugs. So there are some bugs which are urgent, there are some big which are low priority, medium priority. So let's say your system already has some bugs which are low priority, medium, but let's say now the urgent priority comes. So your system should process that urgent priority first actually. So we need to have some kind of priority here, so that's the order, the items will be pulled out of this queue. So we'll do that with the help of an example. Then third thing is priority blocking queue. So this is exactly like same like priority queue, but this provides thread safety. Otherwise it's very similar to priority queue. So thread safety means it provides data concurrency, like no two people can access or manipulate the same element at the same time actually. So that's the only use case for this one. So let's quickly go through some examples. So I'm going to implement let's say this linked list first. So let's see, you can implement queue, and I'm going to, let's say I'm going to just put some numbers in this queue. I say q1 equal to new linked list, and it's of type integer, and we have to just import this one here. We have to import this one, Okay, so let's say I'm going to add some, let's say Q1, and I'm going to add, let's say I add 5, then I add 3, Q1 and 7. So you see I added 3 elements. I'm just going to print them actually. So let's say Q1. Okay, so if I just print them, it will just print these 3 elements, 5, 3, 7. And if you notice, they printed kind of in the same order I put them into, because they are in a linked list, and in the linked list they maintain the order actually of them. So this is one way to print, but you can also iterate through these elements. So there's a way. So let's say you can say iterator itr equal to, let's say you have a Q1. You get iterator of this one on the Q. We have to just import this one. So iterator is nothing but it's a way to iterate through all the iterate or navigate through all the elements of this queue. So first, you from the Q1 you put this function, and it returns you a list of it returns your iterator of integers. And what you can do here is you don't have to really put a for loop or something, because what you can say one has next. So it means as long as there's next element, you want to go through this loop. And here you can just simply print, let's say print, and we go to iter dot next. Next mean it returns you the object really. So what we are saying is you keep looping through this as long as you have elements. So you see this return. So I can comment on the first one actually. So yeah, so you can see 5, 3, 7. So it put the same elements here. Other thing is we want to have, let's say you want to have priority queue now actually. So let's do the same integer q2 new priority queue integer. Yeah, just by having this integers here, I'm just telling what kind of elements are contained this queue. So let's say in the q2, so let's say I want to add 5. Well, you know what, I think I can add the same set of elements here. Yeah, because but instead of q1 I say q2. And if I print this queue, this is q2. So if you noticed, I put still 5, 3, 7. If it was a linked list implementation, it would just print them 5, 3, 7. But this is a priority queue, and as I mentioned, if you don't specify any comparator how the priority should be determined, it will use the natural ordering of the elements. So natural ordering means we know that 3 comes first, then 5 comes, then 7 comes. And if I run this one, you see 3, 5, 7 came. Yeah, this other output came from this iterator here. So I can just comment that out actually. So let's clean it one more time just to make sure. Yeah, so if you noticed, it came 3 came first, 5, 7, because it did the natural ordering of this one. But I mentioned that you can specify you can specify your own logic how the items should be prioritized. So right now it's by lowest, and then goes to highest. But maybe let's say you want to do from highest to lowest first. So you want to really reverse the order. So let's see, we are going to write a comparator here. Then what we can do is we can supply that comparator as a I think it takes one of these parameters. So if you see this priority queue, yeah, it can take a comparator here as a argument actually. So let's try to this example. So we can create a class here. We call it my comparator. Well, now let's see. Now there's a comparator. So let's say oh yeah, there's this interface comparator, and or says must be, okay, yeah. So it says because this comparator has a method called compare, so you have to really implement that method. So let's say we are assuming that this comparator only does for the integers because that's what we had. So what we can do here is we can say integer. Okay, so this you have to define yourself, this comparator, and you can put the logic, what kind of logic you want to have. So what I'm saying is if so it has this interface has a method called compare, so you have to override that method now. So I'm saying we have this method and it takes two parameters, which is integer 1 and integer 2, and you have to provide your own logic. So I'm saying o1 dot okay, if o1 is less than o2, then return usually will return -1 if you want to maintain the natural ordering, but I want to do it reverse, so I'm saying not -1, I'm saying 1. Else if o1 greater than o2, then I want to return -1, otherwise I want to return 0. Okay, so let's see if it works. So we have to supply this. If you notice, I write this class within this class, so that's fine. You can write, but there can be only one public class in the code. So there's one public class, and public class ends here, but there could be more than one file class in a file. So this is why I just created this class. I mean, you could have put it outside too here, in this package, but I just put it here just to keep things simple. So yeah, it's a separate class. So what I want to do here is I want to pass this interface here now. So this comparator. So I just passed the instance of that one, if you noticed. So if you notice, earlier it printed 357. Now it really print 753 because we try to reverse the order actually. So let's see. Okay, so it printed 735. So I think maybe less than o1 less than 2. I think I might have messed it up somewhere, this comparator. So let's see, if o1 less than o2, return 1, as if there should be another else here, because otherwise yeah, because otherwise it always returns something 0 actually. So okay, that's why it happened. Sorry for that one. So still if this is this, else if o1 less than 1. Hello. So sorry for that little issue on this comparator. So what I did is for some reason that integer comparison was not working. I just tried it for some time, and I'm not sure what went wrong there. But so what I'm trying to do is I just try to make a queue which is, instead of integers, now it's containing strings actually, and still the same comparator, and you don't have to really. So still I'm just trying to override the same method compare. It has two strings, o1 and o2. You compare. So because I want to do in the descending order of the strings, so like that's why I put o2 here first and then o1 compared to. So I added four values here, so 3 5 7 1. So I'm going to just run it and let's see. Yeah, 3. Yeah, so because f comes first, f, then s comes, then o comes, then t comes. If you want to really switch the order, we want to really ascending order of this alphabet, so you can do this o1 and o2. That's the natural ordering. And I'm going to run this again. I'm going to just keep these values here so that we can just see. Oh, did clear. So well, yeah, so it's 5, yeah, 1 7 3. Yeah, it is an ascending order, but if you want to descending, you have to just switch these values and it will do other way around. So 5 1 7 3. So then 3 1 7 5. So this order, this is all about doing this function yourself and do this comparison. So other thing, I think I don't want to spend too much time on this one. So let's see. other operations you can do, let's say I'm going to remove this comparison function from here, just make it a regular queue, and I think I can get rid of this one too. So what I wanted to show is, so this is a queue, so, and we know that this Q2. So we know that this queue has this value is 5173. Actually, you know what, I don't even show this priority queue, so let's go back to this our regular queue actually, so that I can just demonstrate what I really want to demonstrate to you. So we have this regular queue, we have 537. So there are some operations. Let's say you want to look what's the first element on this list. So just first element on this list. So we can do, what you can do is, there are some operations. So we can say first element of queue actually. So this is Q1, and you can do this function. There's a function method is called peek. Peek means you just peek through it. You don't do anything, you just peek through it. So let's see. And we know the first element is 5. You should return 5. Oh yeah, first element of queue is 5. Let's say you want to remove the first element. In order to remove it, there's a method called poll, P-O-L-L. So I'm just removing first element of queue, but then I want to print a queue again here, so that we know that there's one less element. So let me clear it out. Okay, so we know the queue is 537. First element of queue is 5 because we did a peek on this one. Then we did after the poll, mean we took the first element, which is 5. So 5 is so. Now the only thing, because we took this out, so then the only thing we left is 3 and 7. So there are quite a bit of functions you can do. You can find the size, isEmpty, those kind of stuff. So also, if you want to empty the queue, you can do something like while let's say q1 dot is empty, or let's say it's not empty. You want to keep basically looping through it and polling it. Polling means just so polling means you just want to removing the element. That's what it is. So you're trying to loop through it. So you're trying to loop through the list until it becomes empty, and just print the element. And at the end, you see this one, list is empty. I mean, this queue is empty. So I think that's all about this queues for this video. So hope you like this video, and please subscribe to the channel and like the video, and I will see you in the next video. Thank you. Bye.